All right, this video is going to go over the test review for quadratics. I'm going to be going kind of fast, so if I move on too quickly, just pause it. And also, if you don't need help in a particular area, just fast forward through the video to the places that you do need help. Okay, let's get started. Number one, they're giving you this equation in standard form. So you need to go get the axis of symmetry in the vertex by doing x equals negative b over 2a. So that's going to be negative 12 over 2 times negative 2. So that's negative 12 over 4. I mean, negative 12 over negative 4, which is positive 3. So x equals 3 is my axis of symmetry, and 3 is the x value of my vertex. Now, to find the y value, you go back to this original equation and plug in 3. So it'd look like this. Okay, so 3 squared is 9 times negative 2 is negative 18, plus 12 times 3 is 36, and then minus 13. That's going to be 5. Y equals 5. So that's the y value of my vertex. So now I can go ahead and plot 3, 5 as the vertex. And then if you want to be accurate about this, you need to do your xy table. But you can't really do your xy table until you know the vertex form of this equation. So you use these numbers, the vertex, to write your equation, y equals. Your a value is right here from the very beginning, negative 2. Then it's x minus 3 squared plus 5. So in your table, you've got your points. You're going to be adding 3 to your x values. You're going to be timesing by negative 2 on your y's. Then you're going to be adding 5 to that. So 2, 3. 3, 5 is my vertex, and 4, 3. So this graph looks something like this. The a value we said was negative 2. We got that from the very first equation. And then the vertex, it's the highest point, so it's a maximum, and this graph is opening down. Okay, next one. This is also in standard form, so you need to run x equals negative b over 2a. So that would look like negative 10 over 2 times 1, which is negative 10 over 2, which is negative 5. This is the equation of the axis of symmetry, and it's the x value of your vertex. You need to go get the y value of your vertex by plugging in, that's a y, plugging in negative 5 here. So it looks like negative 5 squared plus 10 times negative 5 plus 23. That's going to be 25 minus 50 plus 23. So that answer is going to be negative 2. That's the y value of my vertex. You can go ahead and plot your vertex. Negative 5, negative 2 is here. If you want to be accurate about this, you need to do your xy table. But again, you can't do this xy table until you have your vertex form. So write your vertex form of the equation. Your a value is from right here. So it's 1x squared. That means my a value is 1. And then make the vertex match. So x plus 5 squared minus 2. Use your parent function coordinates. You're going to be subtracting 5 on your x's. You're going to be subtracting 2 on your y's. So negative 6, negative 1 is here, and then negative 4, negative 1. This graph would look something like this. The vertex is the lowest point, so it's a minimum, and this graph is opening up. Okay, these are already in vertex form, so you can just jump right into the table. The negative out in front here is a times -1 on this table on the y side. And then I'm going to subtract 4 on my x's. And I'm going to be adding 6 to the y's. Go ahead and plot it. -5, 5 is here. -4, 6. -3, 5. This graph would look something like this. And that's it. Okay, next one. It's already in vertex form, so you can just jump right into your table. This one, the 3 in front, is a times 3 on your y values. Biggest mistake I see is people put like +3 or -3 right there. It's a times 3. This +2 is going to be a -2 on my x's. And then a -4 on my y values. So -3, -1 is here. -2, -4 is here. And -1, -1 is here. This graph would look something like this. All right, moving right along. Describe in words how it's been transformed. So you're just listing out the transformations. So the 9 in front is a vertical stretch times 9. And then the -7 is a horizontal shift. And it's lying to you, so it's really right 7. And in your table, you would add 7. The next one, the negative out in front, is a reflection across the x-axis. The +4 is a horizontal shift, left 4. And then the -8 is a vertical shift, down 8. Okay, the next one, it says state the vertex of this. This one's in standard form, so you have to do x equals -b over 2a. So that's going to look like this -b part just means take b and change the sign. So instead of -4, you write +4 over 2 times a. A is 1. So you get x equals 2 when you do this. So I know like my coordinate is the x is going to be 2. You have to go find the y by plugging in 2 into this equation. So it goes like this: y equals 2 squared minus 4 times 2 minus 3. 2 squared is 4. Minus 4 times 2 is 8, and then minus 3. So this one, 4 minus 8 is -4, minus 3 is -7. Like that. So 2, -7 is my vertex there. Okay, the next one, it's in vertex form, so you can just write your HK. Remember, your H is lying to you. So this one is just going to be 25, comma, -6. All right, these next ones, they want the axis of symmetry. Well, when it's in vertex form already, like this one, the vertex would be 10, 1. Your axis of symmetry is just the x value of your vertex. So x equals 10 would be my axis of symmetry there. Number 10, it's in standard form. So to get axis of symmetry, okay, hold still. To get axis of symmetry, you have to do the x equals -b over 2a. So that's going to be -8 over 2 times 5. So that's -8 over 10. Reduce that fraction and you get -4 over 5 would be my answer there. That's the axis of symmetry and the x value of your vertex. I know it's a fraction, that's okay. Convert to standard form is when you're going to have to do FOIL. So it works like this. I'll just do it on one of these. X minus 6 squared is really like writing it twice. Now FOIL works like this. You do the first times the first, that's x times x is x squared. Then the outside and the inside, so that's minus 6x minus 6x. And then the last is negative 6 times negative 6, which is plus 36. Then you'll have to combine some like terms here. So x squared minus 6x makes minus 12x, and then plus 36. So that's the FOIL of this part. But that's not all of it, because you have x squared minus 12x plus 36, but then there's a plus 4 at the end as well. So you have to add 4 after foiling. So my answer here is x squared minus 12x plus 40. The next one's a little more challenging because you'll do your FOIL and you'll get x squared plus 6x plus 9. But then you're going to have to distribute a negative 4 to all of these things. So it turns into negative 4x squared minus 24x minus 36. And then don't forget, you still have that plus 5 at the end. So you'll have to combine these like terms there. So it's going to look like negative 4x squared minus 24x minus 31. The last one's kind of similar. You'll do your FOIL and you'll get, I'm going to just want a different color so that it doesn't get too confusing over here. You have negative parentheses. Do the FOIL of this part and you'll get 4x squared plus 12x plus 9. But then you're going to have to distribute the negative to all of these things. So it changes all these signs like that. And then you still have like terms at the end that you have to combine. So my answer here would be negative 4x squared minus 12x minus 16. Okay, given the graph, write the equation first in vertex form and then convert to standard form. The vertex is negative 4, negative 1. So vertex form is going to look like y equals x plus 4 squared minus 1. Only problem is this letter A right here. You don't know what that is yet. So you have to go solve for it. And the way you do this is you use a coordinate. So like take this coordinate, for example. This coordinate is at negative 3, comma, negative 4. That is an x, y coordinate. So all you have to do is plug it in for x and for y. So it'd look like this. My y is negative 4 equals a, I don't know, that's what I'm solving for. X is negative 3. Copy the rest of it. Now you just have to work this out. Negative 3 plus 4 is 1. Squared is 1. So this part becomes 1a. Then just finish solving this by adding 1. I got a equals negative 3. Which makes sense because I went down 3 over 1 to get to that, to get to this red dot right here. Sorry about the screen drop. All right, next up is converting it to standard form. Oh, so in my answer, I would change this letter A to be a negative 3. So it'd look like this. Negative 3 parentheses, then the letter x plus 4 squared minus 1. All right, to convert it to standard form, it's kind of like doing this FOIL from above. Basically, you're going to do the FOIL part. You'll get x squared plus 8x plus 16. You'll have to distribute the negative 3 to all these things. So that's going to become negative 3x squared minus 24x minus 48. But then don't forget, you still have a minus 1 at the end. So my answer here in standard form would be negative 3x squared minus 24x minus 49, like that. Okay, next up, convert to vertex form. All right, this one, you're going to have to go and get your vertex. So you have to run x equals negative b over 2a for all of these. So it's going to look like this. The negative b part just means change the sign of b. So now it's positive 16. over 2 times a is 2 right there. So this is 16 over 4, which is 4. So now I know the x value of my vertex is 4. I have to go solve for the y value by plugging in 4 into this equation for x. So it'd look like this: y equals 2, 4 squared, and then minus 16 times 4, and then plus 38. So 4 squared is 16 times 2 is 32, minus 16 times 4 is 64, plus 38. So that's going to give you a value of 6. That's the y value of my vertex. And now I can write it in vertex form. Y equals, my a value was 2 from the original equation. Then make your vertex match. So x minus 4 squared plus 6, like that. The next one, same thing. You're going to have to run x equals negative b over 2a. When you do that, you're going to get negative 2 over 2 times 1, which is going to have a value of negative 1. That's the x value of your vertex. Plug it in to find the y value of your vertex. So that would look like this. Negative 1 squared plus 2 times negative 1 minus 2. So that's going to be negative 1 squared is positive 1. Plus 2 times negative 1 is negative 2. So I'm just going to write minus 2. Then minus 2 at the end for this one. 1 minus 2 is negative 1. Minus 2 makes negative 3. So now I'm ready to write it in vertex form. Y equals, my a value was from the original equation 1. Make your vertex match. So x plus 1 squared minus 3, like that. All right, identify the following attributes. The domain of all these quadratics is all real numbers. So negative infinity to positive infinity. The reason is because these lines go left forever and right forever. So from negative infinity to positive infinity on my x. The range is how low it goes, how high it goes. The lowest it goes is down forever to negative infinity. The highest it goes is right here at 6. And you use a bracket there. That vertex is a maximum because it's the highest point on this graph. This graph is opening down. The vertex is negative 3 comma positive 6. All right, increase, decrease works like this. This red section of line here, from left to right, is increasing. And it's increasing from x values of negative infinity to negative 3. So I'm increasing from negative infinity to negative 3. Remember, use x values when you answer this. Then I've got this green section of line right here. It is decreasing from an x value of negative 3 all the way to an x value of positive infinity. The end behavior works like this. You write as x arrow negative infinity, y arrow blank. And then you do it again as x arrow positive infinity this time, y arrow blank. So this is asking, if you go left, what's your arrow do at the end? It's going down to negative infinity. That's the first answer. Then the second one, as you go right, what's your arrow doing at the end? It's going down to negative infinity as well. So they're both negative infinity. Then axis of symmetry is just x equals and the x value of your vertex, which is negative 3, like that. If they give it to you like this, where it's in vertex form, just make you a little sketch of it. It does not have to be perfect. You would have a vertex of 8, negative 9. Mine is not to scale. I don't really care about that. I care about putting the vertex down at 8, negative 9, and then realizing that this is a positive a value, which means my graph is going to open up like this. And that's all I need to draw to answer all these questions, because the domain is all reals. The range, the lowest it goes is negative 9 there. And the highest it goes is up forever to positive infinity. The vertex is at 8, negative 9. This vertex is the lowest point on this graph, so it's a minimum. This graph is opening up. This red section right here, I guess I should stick to the color pattern. So let's go with green. This green section right here, from left to right, is decreasing from x values of negative infinity to positive 8. So it is decreasing from negative infinity to positive 8. Then it starts, this red section starts increasing. So it's increasing from 8 to x value of positive infinity, like that. The end behavior, you write it like this, as x arrow negative infinity, y arrow blank, as x arrow positive infinity, y arrow blank. So this just means if I go left, what's my arrow do? I'm going up. So my answer here would be positive infinity. Then the next one means if I go right, what's my arrow doing? Well, it's going up as well. So that would be positive infinity as well. The axis of symmetry is just x equals, and then the x value of your vertex, which is 8, like that. Given a vertex and a point, write a quadratic in vertex form. So this one, y equals, list the letter A, make your vertex match, like this. Now, you have to go solve for this letter A by plugging in an x, y coordinate into x and y, just like before. So just go plug in that coordinate. 6 is my y value. A is what I'm solving for. Negative 1 plus 3 squared minus 2. Then just solve it. Negative 1 plus 3 is 2. You're still going to have to square that 2, though, so this part actually becomes 4a. 2 squared is 4. Solve it, add 2. Divide by 4. A is 2. So now I can rewrite my equation. Y equals 2. X plus 3 squared minus 2, like that. Same thing on the next one. Start writing your equation. Leave the letter A. Make your vertex match. Now you're going to be plugging in an x, y coordinate into x and y so that you can solve for A. So it look like this. Y is negative 16 equals A, leave as A. X value is negative 2, like that. Now just go solve it. Negative 2 plus 5 is 3. Squared, which is 9. So this part becomes 9a. If you don't know how I did that jump right there, I showed all my work on this previous one. Okay, minus 2 is negative 18. Then divide. I got an a value equal to negative 2. So my equation would be y equals negative 2 parentheses x plus 5 squared plus 2, like that. Now this last one is solved by factoring. The first one's a difference of squares. So just root each thing. Root of x squared is x. Root of 36 is 6. So you just go x plus 6, x minus 6 equals 0. Set each one equal to 0 and solve. So I got x equals negative 6, and I got x equals positive 6. The next one is a trinomial. So this is where you rainbow and multiply, negative 30. And then look at the middle number, 7. You have to find a combo of numbers that adds to be 7 and multiplies to be negative 30. So your combo is going to be negative 3 and positive 10. Put them over your a value, which is 5. You must reduce. So this reduces to be 2 over 1. Then you can write it in factored form, which would be bottom number, 5, right here, bottom number 5, then the letter x, then the top number, 5x minus 3. Same thing on the next one, 1x plus 2. Set each of those factors equal to 0. You get your answer of 3/5 and -2. You should be able, if you're in Algebra 2, you should be able to solve an equation like that without having me have to show my work. Okay, the next one is a GCF. So they both share a 2 and they both share a letter x. You have to go divide by 2x now. So 2 divided by 2 is 1. X squared divided by x is x. And then minus 14 divided by 2 is minus 7. And x divided by x is just 1. So I'm not going to write that part. So this would be considered factored form. Go set each of these factors equal to 0. So this first one, you would just divide by 2 here. 0 divided by 2 is just 0. And then the second one, just add 7. So you get positive 7. The next one is another trinomial, so you'll have to rainbow. That wasn't a very good rainbow. Rainbow, multiply to -40, and then add up to the middle number. The combo that you're looking for here is 5 and -8. Put them over your a value, which was 1, because it was 1x squared there. Then you write it in factored form, so bottom number x, top number. Set each factor equal to 0 and solve. You would get your answers of x equals -5 and x equals 8, like that. The next one is a difference of squares. So you need to be square rooting this first part and square rooting the second part. The square root of 49 is 7. Square root of x squared is x. Square root of 16 is 4. And one's a plus, one's a minus, like that. Set each of these factors equal to 0. Solve it. Get your answers of -4/7 and +4/7. The next one is another trinomial, so you're going to rainbow. You have to find a combo of numbers that multiplies to be -48 and adds up to be -13. The combo that you're looking for is 3 and -16. Put them over your a value, which was right here. You must reduce. This reduces to be -8/1. Now you can write it in factored form, 2x plus 3 and 1x minus 8. Set each of those factors equal to 0 and solve. So this one would be -3/2, and this one would be +8. The next one is a GCF again. So the thing that they both share is the letter x. Take it out, you'd be left with x plus 8. Set each of these factors equal to 0 and solve. Nothing to it. Then this last one is another trinomial. So you'll have to rainbow and find your combo. So there's two numbers that have to multiply to be 30 and add up to be -11. Your combo of numbers is going to be -5 and -6. Put them over your a value from here. Then write it in factored form. Set each factor equal to 0. And solve it.